Awesome, welcome to this video. So in this video we're going to be looking at load assessment, also known as energy audit. So how do you conduct an energy audit for your client? How do you do a load assessment for a client or at a site? That's what I'm going to be learning in this video. Okay, so about load assessment is all about ascertaining the amount of energy a user uses on daily basis. How much of an energy does the client use on daily basis? Okay, that is what the load assessment helps you to ascertain, and that is one of the most important information or data you need to conduct a system sizing, okay, for a client or at a site. Now after you have collected all this information or data, there are basic calculations you need to understand. How do you ascertain daily load? So there are some formulas you need to be able to do this. So there are formulas for calculating load size. Now let me show you. Daily consumption, if you want to get amount of energy a user uses on daily basis, you are going to do the energy watt hour power. That is the appliances the person is going to power. All the appliances they are going to power, the total watt of it, you times it by the quantity. All the numbers of the appliances they are going to power times what, how many hours that appliances will run in a day. If you do that, you'll be able to get daily load size of any building, of any house. Go to a home now, they told you, okay, we are going to power AC, it's going to run for 6 hours. You check the wattage of the AC, you know amount of energy it consume, you times it by the 6 hours, you get the total hour that AC is going to consume a day. That's what you're going to do to all the products that is going to be powered with solar. You do it with light bulb. Okay, they say, okay, we'll have 10 lighting points, they are rated at 10 watts. What are you going to do? You times the 10 watt 10. You ask them, like, how many hours does this light bulb work every day? They say 10 hours. 10 watts times 10 bulbs times 10 hours. You'll be able to get for that building the numbers of watt hour, the numbers of daily energy they use, the bulbs use every day. You will be able to get it. If you do all this, compile everything and add everything, you'll be able to get the total energy used for the day. Okay, so this is the formula you need. Don't forget about this, take a note. Okay, so this is daily consumption. So if you want to do your total daily load calculation, you do add all the appliances hourly energy consumption to get your total daily energy consumption. So if I've gotten the rated power of AC, I times the quantity, I times how many hours is going to run. I've gotten the load, the total energy consumption of only AC. Okay, so if I do that for TV, fridge, lighting point and all that, after I've done all that and now add all of them up, I'll be able to get my what is called total load. You'll be able to get your total daily load consumption if you add all of the rated power, quantity and hours of all the devices that are going to be powered by solar system. Now this is just an example. This is also to help you note down this formula. This formula is important. Anytime, any day, if you go by this formula, you're not going to mistrack, you're not going to get it wrong. You're always going to get it right when it comes to sizing a system. Now let me show you how we collect data to size a system. Now this is a appliance load table. Now this is what I'm telling you about calculations. Okay, see what we do. Let's say you go to a site, we have this table, I gather this data. You ask the client, how many TV are you powering? You say it's 3 pieces. You check the rated power of the TV is 150, you note it down. So 150 times 3, the total load for that TV to run in what this watt hour is, amount is going to charge to run for 1 hour. So the TV of that load, the TV load in that house is going to charge about 450 watts to run for 1 hour. Okay, that is noted. So you are going to do that to the fan. How many fan? You say 4 pieces. What is the rated power? 750 watts times 4. The entire fan in that building is going to run for, it's going to take 3000 watts, 300 watts energy to run. Okay, the entire fan for 4 hours. Same thing with the lighting point, 1005 hours. Okay, the fridge, 150 watt hour. The hotspot, the AC. Okay, 1 horsepower AC is rated 150 watts. Don't worry, I will show you how this is achieved, how we get to know that 1 horsepower AC is rated 750 watts. Although a lot of people rate it 1000 watt also equivalent, but on the normal calculation is rated 750 watt, and they say they have one. It's okay, it's going to run. So for this AC to run for 1 hour, it's going to eat up to 750 watt energy. This is the pumping machine. So after we have done this, so you go ahead and ask the client, okay, or you get an idea, how many hours does your TV run on daily basis? They tell you, note it down. How many hours does your fan run on daily basis? 24 hours. They tell you, if they say 24 hours, you note it down. Whatever they say will determine the capacity of energy, okay, they use, and also it will going to determine the capacity of solar system you are going to recommend to them. Upon all this, what you can do, because when they all go 24 hours, this energy is going to be massive. It can even be beyond their budget and all that. But at the end of the day, you can now suggest to them or give them some professional advice. But if you really want to size the system, customers say, this is what I want, do it for me this way. This is how you're going to go about it. You're going to get hourly operating, daily operating hours of each of these devices. After you have done that, you times the total of the load power of the quantity, you times it by the hours it's going to run. You are going to get, for this particular TV, if it runs for 6 hours under this 450 watt, it's going to eat up 2700 watt hour a day. So you do this for all the appliances. Okay, with this now, let's say this is for a load sizing for a client or a site or a home. Okay, after we have done that, this is what we have gotten. Okay, we got that this system, this home, with these specifications, okay, they use up to 12,450 watt hour on daily basis. And we got that their total load, the total appliances of load, of which if they turn it on at the same time, is rated at 4050 watts. Okay, so the total load is very, very essential. These are the two major data we needed, are very, very important to us: the total load and also the total daily energy consumption. So this, because of this information, this is the reason why we are doing this. The essence of doing a load appliances audit, the essence of doing a load audit is to get these two information. Okay, because these two information is going to serve us. Okay, these two information, first, the total load is going to help us determine the capacity of inverter that we can use on this system, while the total daily energy consumption is going to help us know the size of solar batteries, the size of solar battery we are going to use to power this system, to be able to power the home efficiently. Okay, so basically that is the essence of conducting this load audit. That is the essence of conducting this load assessment, to get the total wattage and also to get the total daily energy. Okay, to get the total load wattage and also to get the total energy consumption. Okay, so since this have been done, the next thing I want to point to you some important things you need to consider when conducting a load assessment for a client, for a building or a site. There are important things you need to consider, and one of those important things is your load appliances that require 2 times their energy to start up. Okay, so you need to note that there are some appliances, okay, they might be rated a particular watt, but for you to start up, for you to start working initially, it will require 2 times or 3 times of that load that is rated. So appliances that has this kind of characteristics are appliances that uses compressor, that are motor or transformer base or heating element. Okay, so this sort of appliances, you need to consider them when quoting your inverter. You need to give room for those their surges. Okay, so let me list a list of those appliances so that whenever you are doing your load assessment or audit, you will be able to you will be able to have an idea of these appliances and know how to portion them in your load assessment. Okay, so let's starting from household appliances. So we have like refrigerators or fridge. They have the power to have running power about 2 to 3 times of their rated power. They can surge at startup. Okay, so we also have air conditioner. We have heat pump or central AC. We have chest freezers. So motors and washing and dryers, devices on this category also has surging power. We have cloth dryers, we have kitchen food processing, we have microwave, which is more uses a heating element, they have such power. Blender too have such power. Okay, so pumps and fans also, we have pumping machines, they are rated in horsepower. Of course, they have such power. Fans, mostly those modern ceiling fans, they also have such power. We also have power tools like circular saws and drilling or impact drive. So take note, all these devices here, they have such power. So whenever you are quoting them in your solar system, you need to give room for their such power. Okay, so basically that is what I wanted to point to you about these devices that require 2 times of their rated power when starting up. Okay, so another thing I want to help you do, so you saw on our load assessment, a 1 horsepower AC, we rated it as 755 watts or so. Okay, a lot of people will rate it 1 horsepower 1000 watts. So there is a way of converting horsepower to watt. Okay, so it's called conversion factor. So what you need to understand is that in the olden days, horse and watt are used to do some energy tasks, energy works. Okay, pulling of objects, okay, dragging of water, all those stuff. And to measure the rate of energy a horse can pull at a particular spot or time, so then it's rated in horsepower. Okay, then watt has not been introduced and all that. So after the introduction of rating of energy in watts and all that, for you to be able to convert object rated in horsepower, so there is what is called as conversion factor. Okay, so it's not actually in proportion like what people do, that 1 horsepower equals to 1000 watts. No, horsepower is more higher when it comes to wattage. So there is this factor that you can use to be able to convert anything rated in horsepower, convert it to watts, for you to be able to do your assessment properly in wattage. Okay, so the conversion factor here is 0.7457, okay, watts. So 1 horsepower is equals to 0.745 kilowatts. Okay, if you convert this to kilowatt, it's going to be 745 watts. Okay, so one horsepower is rated 745 watts. So with this conversion factor, so if you have anywhere that you have your device rated in horsepower, let's say 1 horsepower, so with this conversion factor, 1 horsepower now will be 0.760 kilowatts. If you convert it to watts, it's going to be 746 watts. Okay, approximately 746 watts. So if you convert 1.5 horsepower to wattage, you're going to be having 1118 watts. So if you convert 2 horsepower to wattage, you're going to be having 1491 watts. So take note of this. So anywhere you have a device rated in horsepower, this is a conversion factor that you can use to convert it to watts, so that you'll be able to plan your system or design your system properly. Okay, so these are the few things I wanted to point to you, how to convert horsepower to wattage, and also to point to you some of these devices, appliances that has such power, that has such starting power. Okay, so I take into consideration when doing your load analysis. So basically that is it about load analysis, that is it about energy audit. Okay, how you conduct all this energy audit. Remember what I said, the most important information we need on this energy audit is our total load and our total daily energy consumption. We need these 2 important information. We are going to use to size other components of the system. Okay, so basically that is it on this load assessment, and I will see you in the next one.